Mitochondria turn food into energy for the body, but if they start to malfunction, free radicals can flood the cells, and a number of health problems might arise. Properly functioning mitochondria are central to health as they generate ATP, or adenosine triphosphate, the energy source that's needed by all cells in the body. Mitochondrial dysfunction is a large cause of age-related neurodegenerative diseases like Alzheimer's, ALS, and Parkinson's disease. The accumulation of free radicals with age results in DNA and protein damage. Mitochondria accumulate defective proteins, and this causes a loss in energy production and ultimately cell death. Improper mitochondrial function has been seen in patients with many diseases, such as type 1 and type 2 diabetes. Heart cells rely heavily on mitochondria to power the pumping of the heart. Mitochondrial dysfunction is therefore implicated in heart failure due to the buildup of oxidative stress. Chronic fatigue syndrome, commonly known as CFS, is a controversial and lifelong disorder, and it's characterized by prolonged symptoms of intense fatigue that can reduce a person's ability to perform daily functions by over 50%. Patients with chronic fatigue syndrome suffer from a variety of other symptoms like anxiety, depression, headaches, muscle pain, and cognitive dysfunction. As mitochondrial support assists with chronic fatigue, it also similarly is linked to increasing endurance in overtrained athletes such as marathon runners and long-distance swimmers. One successful way to boost mitochondrial function is through intermittent fasting. Some possible signs and symptoms of mitochondrial dysfunction include feeling excessively tired, an inability to exercise for long periods of time, shortness of breath, especially during exercise, poor bone growth and health, difficulty controlling movements, balance and coordination, known as ataxia, difficulty walking or talking, muscle weakness and pain, heart muscle disease, known as cardiomyopathy, gut and digestive issues, liver and kidney disease, droopy eyelids, vision loss and other eye problems, just to name a few. One study in 8 healthy elderly volunteers found that just 2 weeks of high-intensity interval training significantly increased mitochondrial function in the muscles. Cold temperatures have a profound effect on the mitochondrial number in animals. Exposing rats to swimming in cold temperatures increased mitochondrial generation by increasing the protein responsible for initial mitochondrial synthesis. Wim Hof, who has many records for cold exposure, was shown to have an increase in mitochondrial function in his brown fat. He achieved this through regular cold exposure and his breathing techniques. One study found that a ketogenic diet slowed down mitochondrial myopathy, which is a muscle disease, in mice, in part by increasing the number of new mitochondria. This is known as mitochondrial biogenesis. In a rat model of Parkinson's disease, resveratrol prevented neurotoxicity by increasing mitochondrial synthesis and improving mitochondrial function. In mice who were supplemented with PQQ for 8 weeks, the mitochondrial function and the number was increased significantly. This was seen as an increase in the amount of mitochondrial DNA found in the cells of these mice. PQQ stacks well with coenzyme Q10 in the form of ubiquinol. Alpha-lipoic acid reduces age-associated mitochondrial dysfunction and is considered a mitochondrial nutrient. In mice, alpha-lipoic acid prevented mitochondrial dysfunction caused by hypothermia. Other studies show that when alpha-lipoic acid is combined with L-carnitine, it may slow aging and be a useful tool for life extension. Guatacola, known as a pseudo-adaptogen, is used to increase blood circulation and cognition. In old and young rats, guatacola for 2 weeks increased the number of mitochondria in brain cells and the mitochondrial function. This was linked to its role in improving cognitive function. Typical doses are 500 to 1000 milligrams per day. Zhaozlang is also known as the herb of immortality. It's a popular adaptogenic herb and it can balance the body in many different ways. In obese mice with mitochondrial dysfunction, gynostemma supplementation for 8 weeks improved energy metabolism by increasing mitochondrial proteins AMPK. Multiple cell studies have found that gynostemma exhibits an antioxidant effect on cells with mitochondrial dysfunction by modifying specific proteins that play a role in mitochondrial activity. N-acetylcysteine is a supplement used for paracetamol overdose, cystic fibrosis, and chronic obstructive pulmonary disease. It supplies you with the building blocks to make glutathione, the main detoxifying and anti-aging antioxidant compound in your body. In a mouse model of Huntington's disease, N-acetylcysteine treatment for 9 weeks reduced oxidative damage to the mitochondria, and it delayed the onset of motor dysfunction. Similar effects were seen in a rat model of Huntington's disease. Doses of N-acetylcysteine can be up to 1,000 milligrams with breakfast, lunch, and dinner. Creatine is often associated with bodybuilding and muscle gains, and there's a lot of myths surrounding it. However, new research shows that it has many other functions in the body, such as enhancing cognition as a nootropic and a study aid. Creatine is a naturally occurring substance, and it plays a major role in the recycling of ATP in the muscle and brain cells. Multiple cell studies have indicated that creatine is effective in restoring mitochondrial function, protecting against structural damage and oxidative stress, and reducing the impact of mitochondrial DNA mutations. Typical doses of creatine are taken in the form of creatine monohydrate at 5 grams per day. However, a larger loading dose can be taken at the start to help to replenish muscle stores more quickly. Berberine has been studied for its life extension properties in that it functions similarly to metformin or glucophage by reducing insulin resistance and protecting against the damaging effects of a high sugar diet, but with less side effects than those pharmaceutical drugs. In fish-fed high-fat diets, berberine supplementation for 8 weeks improved liver mitochondrial function, and it prevented cell death. In skeletal muscle cells, berberine prevented mitochondrial dysfunction by increasing SIRT1 and subsequently the generation of new mitochondria. Common doses are 500 milligrams of berberine hydrochloride taken with breakfast, lunch, and dinner. For more detailed information about the herbs and supplements talked about in this presentation, go to my website.